rather than paying more attention on the sound part, which we will pay, today we'll concentrate on the wave part. Okay, something which is known as wave mechanics. You need to understand this, and a lot of part of wave mechanics will be there in your grade, what you call 11. 11 also, 12 also. So let's understand a little bit about wave mechanics. And once we understand this, we'll go back to sound. There are many things from here also where you'll get numericals and every other thing. If you wish to study in 11 with science, then this it will be a fundamental. Okay, 1 meter. This will be a fundamental topic. Now, wave mechanics, you will say, what is the role of wave mechanics in sound? So, sound is one chapter. Like say, sound is a vertical. Okay. Light will be a vertical. Alternating current will be a vertical. Periodic and simple harmonic motion will be a vertical. These are all topics. Say light you will study in grade 12. Alternating current will study in grade 12. Again, simple harmonic motion will study in grade 11. Wave is like a horizontal. This is the frying pan on which different vegetables and dishes will be prepared. So understanding wave mechanics is very important. And in wave mechanics, basically some parameters, like what do you mean by frequency, amplitude, what is a wave pattern, what are the different type of waves. And we are here learning this because there is a chapter called sound, which is acoustics, which will also show wave pattern, right? So this is something like in easy language, I say this is something like ye love jaisa hai, mother and child love. You grow up, you and girlfriend love, husband wife love for a teacher. So the love is a horizontal. Different actors and players will play the role in different manner. Have we understood? Right. So our job is to understand about wave mechanics today. And in grade 9, we will see the marriage of acoustics. Acoustics is the study of sound in wave mechanics. And further see that wave mechanics will be studied in what you call light and all, as I said. Now, wave mechanics. Before going to wave mechanics, let's understand what is a wave. Okay. A wave is a periodic disturbance. Very interesting. A wave is a periodic disturbance. That means disturbance means periodic, where you can actually predict अगला टक टक कब आएगा. जैसे बाजू के घर में कोई वॉशिंग मशीन चल रहा है और वो खराब है. That washing machine is bad. It makes a noise. Keep. So you know next key-up will come after this time. You can predict it. That's a repetitive motion. That's why we say like a pendulum oscillating, tuck, 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 tuck. That is periodic. You can represent it by wave. Moon going around the earth, periodic, every 28 days. We can represent it by wave. A girl skipping, tuck, 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 periodic. Wherever something is repeating at a constant interval. So a wave is a periodic disturbance. And something interesting is in which particles, now this will become clear slowly. Particles, I'll use the word oscillate. I'll use the word vibrate. I'll use the word move about. Their mean position but the disturbance keeps moving. Very crude definition of wave. A wave is a periodic disturbance in which particles vibrate, oscillate, or move about their mean position. However, the disturbance keeps moving. अब ये चीज को समझने की कोशिश करते हैं with some very basic level examples. Okay, and our first example is where we are at a beach. and somewhere in a country, as I always say, Australia. If you go to Australia in a beach, and then you find there are some lovely birds, we call them guillemot, or like the seagulls. The seagull, very far away. Australia is famous for that. Every cricket match also you'll see them coming. You will find, now what I said, wave is a periodic disturbance. So you understand the water waves are coming, right? So we are standing out here, we are standing out here, and we are taking the water waves are coming, right? I say, in which the particles oscillate. We feel that the water from far across from Gold Coast is coming and touching our legs. No, no. The water which is at our legs, it is there only. The water which is there at Gold Coast, it is there only. Only the disturbance is coming. How to understand? If that would have been case, the guillemot will just keep appearing and disappearing. You will see. ये अपनी जगह फ्लोट करते रहता है. The disturbance comes to you. If there was a water molecule here, this water molecule never comes here. Had that been the case, then everything should have been washed off. This water molecule remains here. This water molecule remains here. This water molecule remains here. All these water molecules keep oscillating or vibrating around their mean position. Sir, what do you understand by mean position? Let's say I find a position something like this. Let's say I find a position something like this. Let's say this is my mean position. The mean position. इसी के ऊपर टक 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 गोते खाए जा रहा है. And the disturbance is traveling towards you. शायद आपका मन नहीं मानता है. ऐसा कैसे सर? वेव हमारी तरफ, आप कहना चाहते हो पानी नहीं आता है. मैं तो कहा कि आपको ये डक आपके पास कभी नहीं आएगा. This guillemot will always be where it is, and you feel what? You feel as if the wave is coming towards you. Right, Aditi, please switch on your camera. Okay, the wave is coming towards you. We feel that. यकीन नहीं करते हैं, विश्वास नहीं होता है. चलो दूसरा एग्जांपल लेते हैं. So recently, the Indian women's cricket team won the match, and we are at the D.Y. Patil Stadium, right? And we got so much excited that we started doing what was known as the Mexican wave. We started from Mexico 1986 when World Cup was played in Mexico. You know what is the Mexican wave, right? So yeah, so there will be different people, and slowly you will see that a wave is moving around in the whole stadium. And we have got people out here. Here there is Sonu Ram, Malti ji, then there is some Renu. Are they moving? Every time the wave comes, they are yay, and the wave keeps moving. अब शायद आपको यकीन हो रहा है. And this fellow is sitting on the opposite side of the stadium. He watches some periodic disturbance, and the cricketers say, the wave has gone up now. But no person is moving. Every person is just climbing up and down at their particular time. From far away, what do we see? Wave is moving. So again, wave is a periodic disturbance, and you know that it is now moving all around the ground. It will come back to you. Wave is a periodic disturbance in which oscillates or vibrates about their mean position, and the disturbance keeps moving. Clear? Sir, अभी भी नहीं मानते हैं आपकी बात को. ऐसा तो नहीं होता है. How can it be? Let's give another example. So our friend Ananya has gone to a gym, and what she does, she's trying to build up muscles. So rope होता है ना, so she's trying to do with the rope. So with that rope, she's now doing rope को ऐसा कर रहा है, टक 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 मार रहा है. And I'm standing from here. It appears to me that the waves are going this way. Then she says, no sir, waves, the particle remains the same. So we tie one small satin ribbon out here. We will see that the ribbon is just going up and down, up and down. But from far away, you will feel as if disturbance is traveling across. Does this get you clear?
Sound.
So sound is different part. Sound is a vertical. Why are you being so biased with sound? Electricity also goes by waves. Light travels by waves. Periodic motion can. Today though we are learning the horizontal, the wave aspect. Sound also, propagation of sound is also like a wave. तो आगे देखेंगे अभी. आपको wave समझ में आया? So wave होने के लिए क्या चाहिए बेटा? एक पीरियोडिक डिस्टर्बेंस चाहिए. एनी पीरियोडिक डिस्टर्बेंस कैन एक्चुअली बी मेड टू शो अ वेव. ओके, उतना अच्छा नहीं समझे सर, थोड़ा और बताइए. वेरी गुड, लेट्स सी अनदर एग्जांपल. अनदर एग्जांपल वुड बी समथिंग लाइक दिस. सो say suppose I have a big paper roll out here, a big paper roll, and this roll of paper we are moving this side. We are moving this paper roll this side. Periodic means the word time also comes. Ek time na tuck 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 tuck. Now we started. Start the stopwatch. Tuck 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 tuck. It's periodic, but time has elapsed. 1 second, 2 second, 3 second, and we start doing a periodic disturbance. This is the roll, huh? And you are pulling the roll this side. ऐसे roll को खींच रहे हो, paper roll को खींच रहे हो. And here I keep a plotter, and the job of the plotter is to go on doing like this. और आप इस तरफ खींचते लेके जा रहे हो. Don't you think the plotter will plot like this? खींचते जाओ. I am pulling it because I can't pull this way. If you want to waste one page, I can show it. I'll just keep doing this. You keep pulling your page. Wave will come out. You agree? A wave will come out. That's how we do it. Another way to understand wave is, say, let's say periodic motion, something that is rotating. Okay, let's take the example. We call it, in electricity, we call it like a phasor. Phasor, say, we can understand waves very nicely. Say suppose I have got, this is the radius. Sorry. So hang on, 1 minute. Let me make some lines. I have a body which is rotating on a cycle. Like say suppose a hammer sort of a thing, okay? I have a hammer sort of a thing which is actually rotating in a cycle. This is one position. There can be one more position here. There can be one more position here. One more position out here. Exactly same. Exactly same. 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 And this we call typically as a phasor. And the phasor is moving in this direction. It is moving. We start it at a time t. We start at a time t. Okay. And now, just see. Let's say both of them were in one level. Okay. In one level. This is one level. And these two are in one level. And say this is in one level. This is a little bit higher level. Let's start from here. All right. So this is my time axis. The middle one is my time axis. You have to appreciate it. Okay. Time axis. Time is moving in this manner. Time is moving in this manner. By the time the ball has moved from here to here, say 30 degree, time has also elapsed. Do you agree? So I say that my initial spot on the time axis is here. This is showing my position out here. After some time, this ball has gone here, right? So अगर ये ball यहाँ गया है, my next position is here. Time, ये time axis है. Next यहाँ तक जाते जाते going somewhere here. फिर ये आते आते here. Time plot. ये आते आते शायद आपको समझ में आ गया होगा. ये कुछ ऐसे जा रहा होगा. This is the wave pattern of this rotation. Every periodic disturbance you can have a wave pattern. So you're getting an idea of what is wave, right? So we need to understand wave now from the perspective of acoustics, that is sound. उससे पहले, let's see some more parameters of wave. Let me draw it once again for you. 1 minute, huh? So let's represent the basic wave. And first time I'm taking my x-axis as displacement. We are showing displacement. Sorry, a small mistake happened. And displacement means we are showing it in meters. And this is the origin. So my wave is shown like this. This. Okay. This is known as my crest. anything above the middle line and anything below is known as my trough. Sorry, huh, children. I had shown it in the whole thing. Okay, so one crest, and it becomes easy to represent in this manner the fact of one crest and one trough. So from one crest to one trough, this is known as one cycle. This can also be known as one oscillation. One oscillation, one cycle of vibration, whatever you say. Have you understood? So to make it more easy, suppose you are representing a pendulum motion. Pendulums also will follow what is known as waves because it's a repetitive motion. So say suppose my pendulum is out here, from here to the next extreme. So this journey is known as 1, 2 that you have learned. And when you come back, it is known as 1 fro. 1, 2 and 1 fro is one cycle. So 1, 2 can be a crest, 1 fro can be a trough. 1 true and 1 fro is a, have you understood crest and trough? Crest and trough is known as one oscillation, one cycle, and in waves language, we call this as, in waves language, we also call this as one wavelength. One wavelength. This is known as one wavelength. Denoted by the Greek letter lambda, written like this. This letter is pronounced as lambda. One wavelength. So what is wavelength? Wavelength is distance covered by wave in one cycle. Distance covered by wave in one cycle. Aditi, if you are hearing me, I need the camera on, beta, unless and until you have some reasons. And that's a bare minimum in my class. Keep on saying that. Okay, if you have some reason, then that's fine. Distance covered by wave in one cycle. In one cycle. मतलब एक साइकिल में वेव कितना डिस्टेंस ट्रैवल किया, वेव कितना डिस्टेंस ट्रैवल किया, ये वेव है ना, ये तो चलते जा रहा है, बिकॉज द पार्टिकल वाज हियर हैज नाउ कम हियर, हैज कम हियर, हैज कम हियर, हैज कम हियर. This is not that particle which is vibrating. This is a part of the wave, the disturbance. Please understand. Disturbance तो move कर रहा है ना. What is the difficulty in understanding? In wave, a disturbance is moving to me. This is the disturbance traveled in one cycle. That is known as one wavelength. One cycle. One cycle. One cycle means moon going around the earth. One cycle. Pendulum. One cycle. Spring. Chiyop, chiyop, chiyop. One cycle. One cycle. One cycle. Any repeating thing, one cycle. एक साइकिल को हम एक वेवलेंथ से दिखाते हैं क्योंकि हर रिपीटेटिव चीज, एवरीथिंग दैट इज रिपीटिंग कैन बी क्लासिफाइड एज वेव. सूरज की रोशनी आपको आ रही है, वेव. मैं बात कर रहा हूं, दैट इज अ वेव, राइट? इलेक्ट्रिकल सिग्नल, ऑल्टरनेटिंग करंट इज कमिंग लाइक अ वेव. So everything which can be shown as a repetitive motion, hacksaw, chang chonk, chang chonk, chang chonk. 1, 2, 1 fro, one cycle. 2, piston of a train, wave. Anything which repeats. बच्चा झूला झूल रहा है, that's also wave. That motion can be represented by a wave. And the wave propagates. The distance covered by the wave in one cycle is known as one wavelength. ठीक है? अच्छा, ये सब जान के रखने से आपको आगे इजी होगा. Let's take 2 points on a wave. 2 points on a wave. 2 points on a wave such that, सुनिए, पहले सुनिए, they are at the same height above or same height below. That is one criteria. More than that, 2 points on the wave which have the same course of motion. Just look at this point. what is his next motion? To go up. He will also go up. Do you agree? Not this point, huh? If I had taken a point here, he is going to come down. दोनों एक ही लेवल में है. अच्छा, इसको और थोड़ा इंटरेस्टिंग करते हैं. जैसे मान लीजिए एक ही हाइट में बनाते हैं. दिस इज माय हाइट. एक ही हाइट में we take some points. Point 1, point 2, and then again point 3. The beauty between point 1 and point 3 is that their course of motion is same. ऐसे points को हम बोलते हैं points on the same phase. ये जो है ना, ये आउट ऑफ फेज है. इसका सेम फेज ये है. समझ में आ रहा है? बड़ा अच्छा एग्जांपल दूंगा, अभी समझ में आएगा. अच्छा, यहां क्या इंटरेस्टिंग चीज है? इफ 2 points you are finding which are on the same phase, then their distance will also be 1 lambda. This is also the definition of wavelength. ये भी 1 lambda होगा. एग्जैक्ट मैच करेगा वो. Any 2 points, any 2 subsequent points, and you will always have after 1. इसका नेक्स्ट वाला कहां पे मिलेगा? यहां मिलेगा. ये वाला नहीं होगा. लेकिन this one and this one will form one wavelength. अब इसका एग्जांपल सुनिए. इसका एग्जांपल, इसको क्या बोला? ये आउट ऑफ फेज है ना. एग्जांपल, 26 January parade going on. We're all soldiers. We all march. हमारा हाथ ऐसे जाता है ना. So all my cuffling is seen. Her cuffling will be seen. Another one's cuffling will be seen. This is the same phase of the wave. वहीं पे एक आर्यस बेड़ा गर्क करता है. हमारा हाथ जब इधर उठता है ना, उसका ये हाथ ऊपर उठता है. Out of phase. Your this hand should have gone up with our this hand. This is called same phase. If you see marching, they're all different points, but they are on the same phase. Row 1 soldier, row 2 soldier. आपको नहीं लगता है वो डिस्टेंस हमेशा सेम होगा जितना दूर मार्च हो रहा है? They call points on the same phase. ठीक है? And 2 points on the same phase also will make one wavelength. This is when we are studying with x-axis as displacement. Clear? और इसमें आपको क्या बताना था? हाँ, yes. Next is, okay, hope it is not getting tough. Next is the maximum rise that you get in a crest. Okay? Or the maximum depression that you get in a trough. This is known as your amplitude. ये तो इजी है. ये देखो, what is amplitude? Deflection from the mean position to the extreme right or to the extreme left. Extreme right, extreme left. इसका और भी एग्जांपल कर सकते हैं. आपके कार के डैशबोर्ड में स्प्रिंग रहता है. Like some toy will be there, one man with his hat on a spring, right? So let's say we have a toy on our car dashboard which is like this, and on here there is one Mickey Mouse. So this is Mickey's mean position. ये मिकी का क्या हो गया बेटा? ये मिकी का मीन पोजीशन है. अब बच्चा क्या करता है? बदमाशी करके इस मिकी को दबा देगा नीचे. तो मिकी कहाँ आ गया? मिकी यहाँ आ गया. और छोड़ देगा. छोड़ने से मिकी कहाँ जाएगा? यहाँ जाएगा. चक्कर 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 ऐसा करता रहेगा. तो ये क्या हो गया? मिकी का एम्पलीट्यूड ऑफ वाइब्रेशन. मीन पोजीशन, एक्सट्रीम राइट, एक्सट्रीम लेफ्ट. सो मिकी का ये पोर्शन को अगर हम वेव में दिखाएंगे, तो इन दैट वेव हाउ मच विल आवर वेव राइज? इतना मिकी नीचे जाता है, इतना ऊपर जाता है.
तो जब नीचे जा रहा है तब भी उसका
हाँ, नेगेटिव एम्पलीट्यूड. ऊपर जा रहा है. अब एम्पलीट्यूड से हम क्या देखते हैं? लाउडनेस. साउंड में आपने पढ़ा होगा. तो वही चीज आइए थोड़ा सा उसको भी देखते हैं. लाइक अ टिपिकल स्पीकर्स विच यू हैव, लाउड स्पीकर्स कैसे बनते हैं? ऐसे बनते हैं. ऐसा स्पीकर होता है. दिस इज द मैग्नेट ऑफ द स्पीकर. सो व्हाट विल यू हैव? यू विल हैव अ मेम्ब्रेन आउट हियर. और ये ऐसा करेगा. डिग 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 लाउड. ज्यादा साउंड इफ यू गिव द वॉल्यूम टू मच, ये क्या हो जाएगा? हट जाएगा. जलवा जलवा ऐसे कर जाएगा. सो दिस इज नोन एज, दैट्स व्हाई यू कांट कनेक्ट द स्पीकर्स आल्सो इन द रॉन्ग मैनर. रॉन्ग करे उल्टा वाइब्रेट करना शुरू करेगा. स्पीकर्स हैव अ पोलैरिटी. So this is the vibration. And amplitude is a direct measure of loudness. Yeah. But later on, when we go to light chapter, वहां भी तो amplitude है. Their amplitude will tell you about intensity. If the amplitude is more, उस light की intensity more है. Amplitude actually talks about intensity of disturbance. Suppose we are on a bridge and it's wartime, tanks are going on the bridge, then the bridge is also vibrating. There is an amplitude is directly proportional to intensity. That means the intensity of vibration. अगर amplitude बढ़ जाएगा तो bridge collapse कर जाएगा. समझ में आया ना? So sometimes they say ये है, ये आप किसी को कितना छूट दे रहे हो, जाओ मस्ती करो. You are giving the control the amplitude. So more you control the amplitude, it will come right to this. So are you clear with amplitude? Because in this diagram, all we can understand is what is a cycle. We can understand what is a crest. We can understand what is a trough. We can understand what is amplitude, and we can understand what is wavelength. And wavelength is measured in meters because this is in displacement is in meters. Clear? I'll change the diagram now. Next diagram, okay? So before that, let me just take off one diagram. That is this one. Okay, so this, we delete this, yes. Right, so we go for another one diagram. Same thing about the wave, okay? So let's take. Now this time, my plot will be based on time. My plot is based on time, same plot. This time my plot is based on time. This is in seconds, right? Last time I saw my how much distance am I covering. So let me make my wave. Okay? What was one cycle? One cycle was one wavelength. That is one crest plus one trough, right? One crest plus one trough, you finished it at this point. And let's say this is that time t. Time taken to complete one cycle is known as your time period. Time period. Time period. It can be 3 seconds. एक पूरा साइकिल मारने में कितना टाइम लगा? अगर आपको मुश्किल हो रहा है इसको समझने में, then let's go by simple pendulum हमेशा याद रखिए. Let's see the simple pendulum. This is your mean position. Agreed? So let's say you started from here 1 and you went this side. This is called, you went to 2, half cycle. Half cycle. Then you again came from 2, so you came this side. This is known as 1 to 1, one cycle. So you started from 1 to 1. At 1, you'll come here, 2, and again 1. Agreed? This portion, this is known as my amplitude. Depends on you. If you take this as plus A, then this one will be minus A. And this is your mean position. Clear? We in later classes we see linear amplitude, angular amplitude, वो सब आप higher classes में आएगा. इतना समझ में आया? ये टाइम करने में आपको जितना लगा उसको हम क्या कहते हैं? टाइम पीरियड. समझ में आया? Now we see a typical scenario. Say this time was 1 second. Say this time was 1 second. ये जो t है ना, this is generic is t, that is 1 second. Say this time was 1 second. Then I will say that the frequency of this wave is equal to 1 CPS, 1 cycle per second. एक सेकंड में एक साइकिल करता है. 1 CPS, which is also known as 1 cycle per second, which is also known as 1 cycle second minus 1. And this second 1 minus 1 in the honor of Heinrich Hertz, the German scientist, is said as 1 Hertz. मतलब एक सेकंड में कितना साइकिल मारता है बेटा? एक साइकिल मारता है. अब जरा रियलिटी को समझते हैं। इंडिया में इलेक्ट्रिसिटी आपको 220 वोल्ट से रेंज में आता है टू 240 एंड द फ्रीक्वेंसी इज 50 हर्ट्ज, which means the current that is coming in those plugs एक सेकंड में कितना साइकिल मार रहा है? 50 cycles. How many half cycles? 100 half cycles. Two half cycles make one cycle, 50 hertz. And if you go to US, then this voltage is 110 volts, 60 hertz. They are the only country who follows this. 60 hertz. 50 hertz means in one second, that current is positive, positive, positive. How many times it is making? 50 times. But how many times? अगर इसको एक bulb ले लो, if you switch on a bulb on a alternating current, the bulb should actually switch on and switch off. At what rate? 50 times switch on, 50 times switch off in 1 second. आप समझ ही नहीं पाते, आपको वो जलता दिखाई देता है. Very slow move, you will be able to see some fluctuation. In earlier days, if there is some those big televisions in any of your grandmother or ancestral house, so those televisions, they're not these LED ones, those work on refresh rate. The screen is getting refreshed, but it is getting, you know, your eye has got persistence of vision 1/16. Anything more than 1/16, you are an idiot, but the camera is not an idiot. Put a camera in front of those TVs, you'll see the screen is rolling, which you cannot make out with your eyes. And the rolling is happening in the cinema theater also. Not today, because these are all digital projections. But if you have the old projections where tuck, 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 the film is rolling, there also rolling is happening. But you don't see that. Your eye has been fooled. Just like we do that time-lapse stories. So this is known as frequency. So better word, but now I said, say if this was 1 second, every time it won't be 1 second, it will be how much? T seconds. So we say in T seconds, you made, say, n number of cycles. In T seconds, you made n cycles. How do you find out frequency? So in 1 second, you will make how much? N by T cycles. So that's your frequency. How do you find frequency? Frequency is in T seconds, you made n cycles. Now let's put our realistic thing. In our example, how much did we make? In T seconds, how much we are making? 1, correct? We are making 1 cycle. So in 1 second, you are making 1 upon T, which tells you that frequency is related to time period as 1 upon T. This is a very interesting find out. Frequency is 1 upon T. आपको विश्वास नहीं होता है, चलिए. Now let's find out the frequency. Now how to find out frequency? So we found that there are 30 cycles, or say 30 oscillations, or say these problems will come to you later on. 30 vibrations you are making in 60 seconds. 60 seconds में कितने vibrations मार रहे हो? 30 vibrations. Therefore, in 1 second, how much you will make? Half vibration. So what is your frequency? Half hertz. Half cycles per second. In 1 week, how many times you see my face? 3. So what is the frequency? What is your frequency you're showing up here? 3 visits per week. So frequent, but in wave language, frequency is always measured in seconds. है ना? तो यहाँ पे हम क्या लिखेंगे? 30 oscillations in 60 minutes, 60 seconds. मतलब 1 सेकंड में कितना मारता होगा? हाफ. तो उसकी फ्रीक्वेंसी कितनी हुई? 0.5. और यही अगर 60 oscillations in 60 seconds, the frequency is 1 hertz. 120 oscillations in 60 seconds, the frequency is 2 hertz. Have you understood? The frequency is 2 hertz. So now you have understood what is frequency. You have understood what is time period. How are frequency and time period related, beta? The frequency is always 1 upon the time period. 1 upon time period. So this is one formula which we will be using a lot in our calculation. Please use it. The second is we use something called C, which is the wave speed. The wave is going at a speed of C meters per second. Have you understood? Fast wave है, fast Mexican wave है, तो आपको देखिए क्या जा रहा है, fast wave. Slow wave. Oh, that's a slow wave. So C is given by the product of lambda into frequency. Wavelength into frequency is speed, and this is true whether you are doing sound, light, electricity, कुछ भी पढ़ो. Speed is equal to wavelength times frequency. Let us see whether we are getting the right unit or not. What is the unit of speed? Meters per second. What is wavelength? Wavelength will always be in meter. Frequency will always be in hertz, which is second minus 1. That's why I have used that. So meter per second, that's the speed of the wave. ठीक है, ये सब क्लियर हो जाएगा, आप कोई भी प्रॉब्लम आराम से कर पाएंगे.
Negative second. What?
One cycle, one CPS, one cycle per second, one cycle per second, one cycle per second is one cycle minus 1. That minus 1 is known as hertz. Second inverse is called hertz, so we call it. वही तो साइकिल पर सेकंड को ही हर्ट्ज बोलते हैं ना. हर्ट्ज बोलना और सीपीएस बोलना एक है. आपकी लैंग्वेज इशू, आप कैसे बोलो. I can call this voltage of India as 220 volt, 50 CPS I can call. Many radios will write CPS, the same thing as 50 hertz. CPS means cycles per second. RPM means rotations per minute. RPS means rotations per second. So nobody goes by RPS, we go by RPM. That is circular motion. These are in linear में पढ़ रहे हो अभी आप. इतना समझ में आया? Okay, थोड़ा सा रिवीजन करते हैं अभी. आप मुझे बोलिए, क्या आपको अब तक you understand what is wavelength? Distance covered by a wave in one cycle, usually represented by lambda in meters. Do you understand what is amplitude? Amplitude से आपको grade 9 you won't get any mathematics. Amplitude is only for logical answering. Amplitude is the max displacement about the mean position. Very good. About the mean position. Mean position. That means amplitude can be positive, can be negative also. Amplitude is like कितना डामाडोल मारते हरे राम, ये एम्पलीट्यूड कितना. ठीक है, ये समझ गए हम लोग. अच्छा, क्या आप क्रेस्ट समझते हैं? क्या आप ट्रफ समझते हैं? The positive displacement is known as crest, the negative displacement is known as trough, right? Do you understand that lambda is equal to 1c plus 1t, one trough? Take. Just for knowledge, do you understand phase? 2 points are said to be on the same phase if they have the same course of motion. Two adjacent are said to be in same phase, and the distance between 2 points in the same phase is also one wavelength. Two phase means two subsequent. There can be phase. Between these two is one wavelength. Between these two is clear. अब कुछ basics देखते हैं. इतना हम समझ लिए. Okay, very nice. Now, then we said that we got to know something called frequency, and also got to know something which is known as time period. Time period is time taken. T for one cycle, time taken for one cycle, and this means number of cycle per second. एक साइकिल के लिए कितना सेकंड? ये कहता है एक सेकंड में कितना साइकिल. एक आम कितना रुपए का? 1 रुपया में कितना सा आम का हिस्सा? अगर एक आम 1 रुपए है तो 1 रुपए में कितना आम? एक आम. So if time period is 1 second, then frequency is also 1 hertz. 1 रुपए में एक आम, 1 रुपए. 1 mango costs 2 rupees. That means in 1 rupee I will get half mango. 1 mango costs 2 rupees. So in 1 rupee I will get half mango. Frequency is half. 1 mango costs 50 paisa. So in 1 rupee I will get 2 mangoes. Frequency is 2 hertz. समझ में आया? यहाँ से एक और रिलेशन आएगा हमारा. That is frequency is equal to 1 upon time period, and also time period is 1 upon frequency. Very, very handy. Then the next one we get is the wave speeds. Wave speed c is given by frequency into lambda. This is known as wave speed, which is equal to frequency multiplied by wavelength. Frequency multiplied by wavelength. अब यहाँ थोड़ा सा और इंटरेस्टिंग बात करते हैं, ठीक है, अब मजा आएगा, ये देखो. Now we spoke about the sun in some chapter. कहाँ में पढ़ा था? आज यहीं पे तो पढ़ा था. The sun gives you what? The electromagnetic spectrum. Gadi XUV in my range, right? So in that Gadi XUV in my range, we said that there is a wave called microwave, and there is a wave also known as radio wave. So we see the micro and the radio. This is actually responsible for all sorts of communications and entertainment. Communication and all entertainment. All sorts of entertainment that you are seeing, audiovisual. Now, they're all coming by what? They're all coming by the speed of light. What is this? So here also the same thing should work. F into lambda. So what is the speed of light? 3 into 10 to the power 8 meter per second, which means whether you are working on a gamma, Gadi, X-ray, ultraviolet, light, infrared, micro, then radio, everyone's speed is how much? 3 into 10 to the power 8. तो गेम किसमें खेल रहा है? सबके फ्रीक्वेंसी और वेवलेंथ में गेम हो रहा है ना? It's like 6. 1 into 6 is also 6. 6 into 1 is also 6. 3 into 2 is also 6. 2 into 3. So let's say you have something called, say, Star Plus. Star Plus is being transmitted by Tata Sky on some bandwidth and wave. So the Star Plus will also have some frequency and some frequency and some wavelength. If you can get this information from Tata Sky or whoever this band they're giving it at, this will come exactly. एकदम तो 3 नहीं आएगा. 2 into 10.99 into 10 to the power 8. सर आप यकीन के साथ कह सकते हैं. I'll tell you my interest. When we were taught at that time, these Tata Skies and all were not there. We used to have radios. So whenever a radio station starts, there is a call sign of every station, and that's lovely to hear. This is the BBC broadcasting on. I used to have my ear stretch on 11.5 megahertz on the short wave, and on the meter wave, they will give you the wavelength on 28.9 meters. वो मैं सुन लेता था. And then I used to go and multiply both. Yes, 2.99. In fact, last year classes I did. You can go to internet, you find out Vivid Bharati, AIR, All India Radio, anything you find out. If you can get their frequency and wavelength, they have to transmit in this, because ultimately the match is all happening here. ये भी interesting है, ठीक है? और इसको prove करने के लिए, what I used to do, I used to anxiously wait for 15th August. 15th August is the date when the Prime Minister will be addressing the nation from the Lal Killa. So in our days, what we had? Television, Doordarshan, we had radios. So I used to switch on one radio on medium wave, one radio on short wave, and one the television, because it's the same thing coming live. So Rajiv Gandhi used to be the Prime Minister, and he used to say, Bharat ki Akhandata, television will say Bharat ki Akhandata, then the short wave, Bharat ki Akhandata, then the medium wave radio says Bharat ki Akhandata. And my dad used to scold, he said, क्या करते रहते हो? मुझे बड़ा मजा आता था. That yes, everywhere the speed, because the wave speeds are different in medium wave, short wave, and others. So you can get to know that. Sometimes I don't know whether you have watched or not. You might be watching a movie, cricket match on Hotstar, and the house beside you must be watching it on Hathway cable. आप देखोगे उस घर में ये हो गया, मतलब विकेट गिर गया है, आपका अभी भी नहीं हुआ है. You are getting a delayed feed. And then my wife and we used to say, wicket has fallen. They have shouted, right? Because they are watching it on a different bandwidth. And this is what is time travel. Today, Aryesh moves his head. I see it from here because light is traveling at the speed of what? 3 into 10 to the power 8. So I see him live. Let's say one more interesting thing. देखो कितना कुछ है. As I say, This is Earth. This is Earth. And this is our nearest star, Alpha Centauri. This is the nearest star to Earth. The distance is 4.25 light years. What is light year? Distance traveled by light in 1 year. Light travels 3 into 10 to the power 8 meter per second, that is per second. So in 1 year, light will travel 365 days into 24 hours into 60 minutes into 60 seconds. This is 1 light year. Can you understand? 3 lakh kilometers. This is 3 into 10 to the power 8, 3 lakh kilometers, 3 into 10 to the power 8 meter per second. So this is the distance. This is 1 light year. How far is this star? 4.25 light years away. And this star is my nearest. आपको शायद समझ में नहीं आ रहा मैं क्या बोलने की कोशिश कर रहा हूं. आज का डेट क्या है? 5 नवंबर 2025. आज रात अगर आप ये स्टार को देख रहे हो, यू आर सीइंग 4 नवंबर 2021 को जो लाइट निकला है 4.25 ना, अप्रोक्सीमेटली 4 लाइट ईयर्स. बासी स्टेल स्टार देख रहे हो आप. This is the nearest star. The light which left this star on 4.25 ना, another ये 11 को भी हटाओ यार. 25 means 4 months. There are 4 months gone. So this will be around some 6 June, 4th June 2021. The light that left, that light you are seeing today. So you are seeing a stale star. And the most important things, we have got many stars which are more than 200 light years away. ये तो आपके जन्म से भी पहले, इंडिया की इंडिपेंडेंस से पहले, even before 200 light years means you are seeing the light of how many years? 1925? No, 1825, before the first war. Means that star कुछ तो मर गया होगा, आप उसी को देख रहे हो. So this is the concept of time. This is time travel. Now, I have weighed out here, and let's say the maximum speed that is there in this world is that to light 3 into 10 to the power 8 meters per second. This is the concept of parallel universe. If he can travel faster than this, he can see a fresher version of this star. So that concept, अभी थोड़ा drift हो गए हम topic से, but it's like this. There is a vakul here as a kid. There is an elderly vakul also who is coughing here. There is a adult. There is a middle vakul also. All are there as per the concept of time. We travel by light speed. Therefore, every 24 hours, 1 day. Every 30 days, 1 month. If he could have traveled faster than light, he can see himself there. He's there. That is what when Devi Devtas used to say, na, they have that power. ये कोई झूठ बात नहीं बोल रहे हैं. That is what is explained in that movie Interstellar. Right? You are having your own. There are 2 lovely movies. One is The Curious Case of Benjamin Button, where a person and his wife reverse age. As the man dies, the wife becomes a baby. So there will be a junction when they will have same age. And from there, life starts becoming again different. Watch that movie. Lovely. And one is Interstellar. 2-3 बार आपको लगेगा समझने के लिए. So you actually, when the father has come back, he has come from a faster world. He is seeing the same daughter. Father is young. Daughter has aged. मैं time travel करके आ गया हूँ. So in less amount of time, I traveled more. And last scene they show that the daughter is with ventilator, father is dashing young as he has left. Very, very strange. तो इसी को तो हम कहते हैं time travel. अगर आप इससे ज़्यादा speed में जा सकते हो, तो आप इसी को देख के आ रहे हो, future को देख के आ रहे हो. And you're coming back. Right? So these are all interesting things. So what I was saying, so are we now fine on these concepts like speed and this? Okay. So इतना तक आपको समझ में आया. अब एक और चीज बात कर लेते हैं. 10 मिनट है हमारे पास. Some 2 more aspects of wave. One is amplitude को सर आपने उतना समझाया नहीं. So let's learn कि amplitude के साथ क्या होने वाला है. Amplitude देखते हैं. आ जाओ. So amplitude is a measure of how much is the displacement, right? So, let's pick up some waves. Okay, 90 degree. So let's say we are listening to one hit song. Yeah, the song is something like टिप टिप बरसा पानी. ये गाना हो रहा है. ये क्या है बोलो तो? टिप टिप बरसा. Same song. There is no change in melody, but amplitude is more. ये loud है. What will you call it? Loud. Very good. Let's see one more. Now, in terms of time, let's see in terms of time. अच्छा, time में देखते हैं. This is one wave. Same loudness, double the frequency. ये मर्द की आवाज है. आओ. ये लड़की की आवाज है. My throat is broken, so I can't tell you like that. ये लड़की की आवाज है. Same song. Now let's go to the keyboard. If you have little bit experience about a keyboard, every keyboard has a button which we call as what? The middle C. ठीक है ना? एक middle C रहता है. ठीक है? तो एक middle C और आगे जाके आपको फिर एक और C आएगा. E A D G B E ऐसे करके एक और C आएगा. इन दोनों में खासियत क्या है? If this one is vibrating at F hertz, this is vibrating at 2F hertz. इसलिए छोटा बच्चा गाना गाएगा, I will pick it up in the higher scale. आदमी गाना गा रहा है हम lower scale में, bass, trebles will be found in this. So if you see a typical bass, the bass sound will, they are all in kilohertz, whereas treble will come in higher range and vocals come in between. So when we do our graphic analyzer, there should be, if you give up too much of bass means you are reducing the frequency. You can feel it. If some music is going on, right? Therefore, in a 4.1 sound system, what is 4.1? You'll have one center and 4 speakers, right? So have you understood? This is what this is a higher frequency sound. Higher frequency means higher energy. अच्छा ये क्या है बोलो तो? What is this?
More loud and high.
Baby crying at night. Loud plus high frequency. अच्छा एक बात आता है, loud sound दूर से सुनाई देता है कि frequency, not loud. If I play the music system loud, maybe maximum this floor and one floor below will hear. You can't expect N tower to hear my music system. But if the child cries at night, वो गिरधारी तक भी सुनेगा. Frequency is shrillness. So another word when we come to sound, in sound we replace frequency by another thing which is known as shrillness. So whose sound is most shrill? A female kid, followed by male kid, followed by female adult, followed by male adult, followed by female adult. So female adult shrillness, highest will be whom? The female kid. Her sound is maximum shrill. Pitch is very high. Acha, this is also known as pitch. Pitch word is used in sound and in threads. Between two threads, we say one pitch. Means one cycle, basically. एक ही concept है. Thread भी तो ऐसे ही घूमता है ना. The thread also goes as a wave. That's how the thread is getting inside. Have you understood this? Loudness देख लिया, pitch देख लिया है. So you hear, now you understand. The impact of amplitude will always be on loudness. The impact of frequency will be always on shrillness, will be always on pitch. Then we'll come to another word which is called timbre. Timbre will actually make you differentiate on quality of sound. Why does his voice, he can sing the song on the same melody, I can sing the song, but you'll say, ye Arish ga raha hai, ye Jaideep ga raha hai. How do you get to know? We'll maintain the same frequency. That's called timbre. A guitar playing jingle bell, and a flute playing jingle bell on the same C scale, but you can get to know this is guitar, this is flute. How do you get to know? by the quality of sound, and that word is known as timbre, Timbre, and frequency. Yeah, oscilloscope that can measure everything, even your whispering and all. An oscilloscope will give you everything that will come up. You just connect it to any sound making device, guitar, just and it can even give you, put a voltage signal also, it will tell you how good the voltage is. What I wanted to tell more, amplitude we have covered, frequency we have covered, shrill. Okay, one more, last thing. Then you have something called the human ear. It is a grade A stuff. And the human ear can hear from 20 hertz to 20,000 hertz. 20,000 hertz. Anything below this is known as infrasonic. Infrasonic. Rhinos communicate with infrasonic sound. And anything above this is known as ultrasonic. Chuha and all. That's why if you go to like big Amazon go downs and all, they will have ultrasonic repellents. To you, they appear just like boxes. But if you were a rat, noise is being created. Noise is being created. Have you understood? So they cannot bear that. Bats make ultrasound. Then there is something called speed of sound. Speed of sound. Speed of sound in air is around 344 meters per second. This is known as sonic. If you travel below it, it's called a subsonic. Like your Indigo and all are subsonic. And all your Rafale and all are supersonic. They are traveling more than the speed of sound. And this is called Mach. Mach 1. और सुनते हो ना वो क्या था? Not Mission Impossible. Mach 10. What was his name? B. Are his helmet, yeah. Tom Cruise. B. We don't watch the Tom Cruise movies, not
Top Gun.
Top Gun. Top Gun.
Maverick.
Maverick. So Maverick takes is on Mach 7, Mach 8, Mach 9. By that time, the gravity is on G-force. The G-force in face becomes like this. So BrahMos is Mach 3. Goes more than the speed of 3 times the speed of sound. उठने से पहले तुमको फोड़ के चला जाए. So that's called Mach. Mach 1, Mach 2, Mach 3. This much. In our next class, we now go back to, because there will be some problems which we'll be doing on echo, some problems on speed and all. So keep an eye on these formulas that we have written. And next class, we will see what are different type of waves, what is a sound wave, because we have to now marry sound into this chapter. But these fundas remain same whether you are studying sound, light, simple harmonic motion, rotational motion, periodic motion. ये change नहीं होगा. ये एक horizontal है. This is like highway. Everyone rides it. ठीक है? आज इतने में रखते हैं. And then we will go on our next class.